Okay, so picture this. You're starting a brand new Go microservice. You've got the requirements, you pop open your editor, and boom. Right away, you're hit with a series of decisions that are going to lock you in for years. Most of us just jump in, right? We write an HTTP handler and think, I'll figure out the rest as I go. But then, 6 months down the line, we hit a wall. The architecture we just kind of accidentally created can't support the new features we need. So today, we're going to build the blueprint before we write any code. And trust me, this is the difference between a service that lasts for years and one that needs a total rewrite in 6 months. And this quote it brilliantly nails the core problem. So many projects start with the pretty stuff, the features, the cool libraries. That's the wallpaper. But they completely forget about the foundation. In this explainer, we are pouring the concrete. We're setting that foundation so that whatever you decide to build on top of it will be solid and built to last. So here's the crucial point, the thing you have to remember. Architectural decisions are, without a doubt, the hardest and most expensive things to change later on. A little chat about repository structure that takes maybe 30 minutes on day one, well, a year and a half later, that can turn into a massive multi-month migration project. This is why senior engineers invest this time up front, because they felt the pain of trying to fix a cracked foundation. Okay, let's dive into our first major decision layer, repository structure. This choice is huge. It dictates how your code is organized, how your CI/CD pipelines are going to work, and maybe most importantly, how your teams will coordinate with each other. So let's look at the mechanical trade-offs here. In a monorepo, it's all in one place. Sharing code is just a direct import. And making a change that affects multiple services, that's just one single atomic pull request. It's clean. With multi-repos, each service gets its own little home, which is great for team ownership. But that shared code now becomes a versioned module, and this is where the pain comes in. With multi-repos, a seemingly tiny one-line change to a shared library can just explode into a total nightmare. All of a sudden, you're creating 5 different pull requests, coordinating 5 different code reviews, and managing 5 different deployments for one tiny change. That, my friends, is dependency hell. And the time you burn on that coordination is the single biggest tax you pay for using the multi-repo approach. So, how do you choose? Well, here's the key insight. This isn't really a technical decision at all. It's about the cost of team coordination. For a small team, let's say under 20 engineers, a monorepo is almost always the right answer. The overhead of managing all those different repos and versioning libraries it's too much. But for a big organization with over 50 engineers, you want multi-repos. Teams need to own their deployment cycles without getting blocked because some other team's CI pipeline is failing. So just remember this. The right choice isn't about which one is technically better. It's about matching your repository structure to how your team actually communicates. Okay, so you've chosen your repository structure. That's a huge decision done. Now, how do you make sure that decision actually sticks? And more importantly, how do you save your team from re-arguing the same thing every 3 months? This brings us to our next layer, writing your decisions down as official documents. And this is where architecture decision records, or ADRs, come in. An ADR is really simple. It's just a short document that outlines a significant architectural choice. I want you to think of it like a court ruling for your code. It states the decision, the legal reasoning behind it, and the consequences. Now, future discussions don't have to re-argue the same point from scratch. They just cite the ruling. Without it, every new engineer who joins the team is going to ask, hey, why did we do it this way? And you'll waste hours relitigating the past. Here's a perfect example. We're deciding to use Postgres for 2 jobs. It's our main database, and it's also going to be our message queue. We'll use a simple technique called the transactional outbox pattern, which is just a fancy way of saying we write events to a table in the exact same transaction as our other data changes. Why do this? Because it's dead simple. It means we don't have to add Kafka or SQS or some other piece of infrastructure that we have to manage. The ADR makes our philosophy crystal clear. Start simple and only add complexity when we can prove we absolutely need it. And here's another great one. All database access will go through a repository pattern interface. This creates a hard boundary, a firewall. Our business logic doesn't know and it doesn't care about the database. This makes our handlers super easy to test with mocks, and if we ever have to switch from Postgres to something else, the change is totally isolated to just one place, the repository implementation itself. Okay, so we've decided on our repository structure. We've documented our key architectural choices. Now it's time to make these abstract principles concrete. And we do that by scaffolding the project's directory structure. This is where the design actually starts to become code. Now, this is the standard CMD/internal layout, but the real magic is in the flow of dependencies. Notice how everything points inward? See how the arrows all lead to one single place? The domain package? And this isn't just a friendly suggestion. The internal directory is a boundary that's actually enforced by the Go compiler itself. It prevents other projects from importing your private code. Everything revolves around and depends on the domain. I want you to think of the domain package as the constitution of your service. It defines the core entities and the rules of your business. It has zero external dependencies, no database drivers, no HTTP libraries, no loggers, nothing. It is pure, unadulterated Go business logic. Every other package in your application must adapt to the Constitution. The Constitution never, ever adapts to them. And this brings us to maybe the single most important rule for a clean architecture. So listen up. Look at the left side of this slide. You must never do this. Never, ever mix your JSON API tags and your DB database tags in the same struct. This changes your API contract directly to your database schema. If you change a column name, you break your API. Instead, you follow the pattern on the right. You have a pure domain type, then you have separate types for your API layer and your repository layer, and you write simple functions to map between them. This separation is the absolute key to a maintainable system. So how do we wire all of these separate pieces together? This is the point where people often reach for a big dependency injection framework. But in Go, the idiomatic way is so much simpler. As this quote says, the best DI framework is the Go compiler. You just create your concrete types in your main.go file, and you pass them around as interfaces. It's explicit, it's readable, and hey, if you forget something, your code just won't compile. No magic, no reflection, no debugging a framework at 3 a.m. So we've covered a ton of ground. Let's distill all of this down into a final, actionable checklist. These are the 5 things you should define before you write your first line of Go code. Okay, so to put it all together, here is your pre-code checklist. 1. Decide on your repository structure, monorepo or multirepo, based on your team's size and how they communicate. 2. Define your core data model. What are the pure central entities of your business logic? 3. Map out your API surface. Know exactly what endpoints your service is going to expose. 4. Write your key ADRs. Document your 3 to 5 most critical technical choices to save yourself from future arguments. And 5. Scaffold the @internal project layout, creating that constitution, your pure zero-dependency domain package, right at the very center. And that brings us to the end. I want to leave you with this one question to think about. If you actually took the time to deliberately define these 5 areas before you started coding, how would that change the outcome of your next project? How much time, how much rework, and how much frustration would you save yourself? This isn't about slowing down. It's about building a solid foundation so you can go faster for much, much longer.